Welcome to the DC Circuits Lab. This is the handout you should have in front of you to complete this lab. It starts off by showing a collection of symbols that you can use in your schematic drawings. For this lab, you'll probably only need the wire, the battery, the ammeter, the voltmeter. For the Christmas tree lights, you can use either the bulb drawing or the resistor drawing, whichever you prefer. And I'm sorry, not the battery, but the power supply. We're going to use a power supply, not a battery. Later, you can look up these, the definitions of these words here and fill out this, but for now, skip that and come back to that later. All right, here is an example of a simple circuit, and this shows some of the equipment, or all of the equipment that you'll be using in the lab. You'll have a power supply, and you'll have a meter to measure current, and you'll also use the same type of meter to measure voltage. So the power supply provides the voltage and the current for the circuit. On the front of the power supply, there are two plugs, one labeled plus and one labeled minus. Place the red wire that comes with the power supply into the plus and the black wire into the minus. Then you'll connect your circuit. Here I've got my ammeter that measures my current connected in series to a wire that goes to a resistor, which then is connected to another wire that goes back into the minus terminal of the power supply. That loop is necessary for current to flow. If this circuit is detached or disconnected anywhere along this circular or this loop path, the current will stop flowing and the circuit will be incomplete. You always have to have a complete loop from the plus to the minus for the circuit to be connected and to work. Here you can read about the ammeter and the voltmeter, and it's important to know that the meters don't affect the circuit. When I place the meters in the circuit, it doesn't change the way they operate. So for example, if I'm putting my ammeter in series, it needs to have a very low resistance, and it does, so that when you put it in series, it does not affect the circuit. Conversely, the voltmeter, because you connect the voltmeter in parallel, it has a very high resistance, so it does not affect the circuit. And conventional current here, it tells us that the conventional current always flows from the plus to the minus, and I have labeled the path the current takes here with marker on the paper, and you can see the direction of the arrows always flowing in the direction from the positive terminal to the negative terminal. And if you connect your meters that way, always putting the red probe on the side where that's closest to the positive, then you'll get a positive reading in your display up here. If, for example, I had the red probe below and the black probe on top, then I would get a negative reading in the voltage window. It would still say negative 4.25, but the negative sign just tells me that I've got my probes switched. If you accidentally get your probes switched around, it's no big deal. You can just use the number in the display and ignore the negative sign. Here we see in my sample circuit, I have 4.25 volts across my resistor right here, and flowing through the circuit is 0.02 amps. All right, on the next page, take time to draw a schematic of this circuit right here, but use these symbols. I'm not asking you to draw a picture of the circuit. I'm asking you to draw a schematic. Use these symbols to represent these things and draw the circuit in this space right here. All right, here's my setup for part one. I've got my meter, I've got my power supply, and I've got my first circuit set up, 3 bulbs in series. When I turn the power supply on, I can see the bulbs light up, and I know that my current is flowing from the positive terminal of the power supply through this red wire, through the first bulb, through the second bulb, through the third bulb, and back to the power supply. there's my complete loop that's necessary for the current to flow and the circuit to be complete. Now what I want to do first on our instructions, it says the first thing we want to do is measure the current. So I'm going to take my meter and I'm going to put the red plug into the hole that says A for amps, and I'm going to turn the dial to the yellow A with the straight line for measuring DC amps to the 20M/10 setting. I'll turn my meter on. I'll set it to the side. Now to measure current, I need to put my meter in series. So my first measurement is between the power source and bulb 1. So here's my power source, here's bulb number 1. So right at this location here is where I want to put my meter in series. To do that, I have to disconnect the wires. You'll see that the circuit turned off because the loop is broken. And now I'm going to take my meter and I'm going to connect it in series by placing the red probe here and the black probe here. You'll see that the lights came back on because my circuit is complete once more. The current is flowing from the red wire into my red probe, which goes through my meter and then back out through the black wire of the meter and back into the circuit over here and then through the bulbs and back to the power supply. And I see that my meter reads 0.16 or okay, 0.16 amps was between the power source and bulb 1. Next I want to measure the current between bulb 1 and bulb 2. So I'm going to go ahead and reconnect my circuit, and now I want to disconnect it between bulb 1 and bulb 2, and that's where I want to put my meter in series so that I can measure how much current is flowing at that point in the circuit. Takes a little coordination there. Okay, there we go. 0.17 again. I'm going to reconnect that up. Record the 0.17 in my data table. And next, between bulb 2 and bulb 3. So I'm going to disconnect the wires here now and put my meter in series at that point of the circuit, and I see 0.17 amps once more. I'll record that in my data table. And now I want to measure between bulb 3 and the power source. So I'm going to reconnect my wires at that part of the circuit and disconnect over here and put my meter in the circuit over there. Whoops, sorry, it came disconnected. There we go. 0.16. Record that. And I see that, like I said, that last decimal point fluctuates a little bit. So 0.16 and 0.17, we can consider those to be the same current. So we see that the same current is flowing throughout the whole circuit. We measured 0.17 amps here, 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 and here. So that shows us and proves that the current through series bulbs is the same. Okay, so here are my 3 series bulbs. I'm going to take the voltage first across the voltage across the power source. So that'll be the voltage between the black and the red wire. And I see there I've got 6.54 volts. Now I'll take the voltage across the first bulb, 2.76 volts. Taking the voltage across the second bulb, 1.81 volts, and across the third bulb, 1.90 volts. 1.90. All right, here's our circuit for part 3, measuring voltage and current in parallel circuits. What I've got is my power supply connected to two bulbs that are in parallel to each other. Then after that, in series with a single bulb. You can see these two bulbs are much dimmer than this bulb. In the video, if you can't see that they are on very dimly. Hopefully you can see that, but they are on. And so, turn the page. Of this circuit, you're asked to draw a schematic of the circuit. So draw a schematic of the circuit right there. And now we're going to, P7, using your ammeter, separately measure the current going in and out of each circuit element in the data table below. So the first place we want to measure the current is between the power source and bulb 1 only. So here, let's let the orange colored bulb be bulb 1 and the blue colored bulb be bulb 2. So to measure the current through just this bulb, I'm going to have to separate that bulb from the circuit. And now I'll want to put my current meter between this point and this point so that whatever current is going through this bulb also goes through my meter. So I'm going to change the setting on my meter to measure current. And I will put one probe there and the other probe on this side of the light. There we go. And I can see that I've got 0.11 amps of current through the orange bulb, which we'll call bulb number 1. Next, I want to measure the current through between the power source and bulb number 2 only. So I will switch the setting here. I'll connect bulb 1 back to the circuit, and I'll put my meter between bulb 2 and the power supply. There we go. So now I've got 0.12 amps through bulb number 2. Next it says measure the current between the two parallel bulbs and bulb number 3. So I'll connect it back the way it was before. There we go. And now I want to measure the current between the parallel bulbs and the single bulb. In other words, what's the current going through the yellow wire? So I have to disconnect the yellow wire, and I'll place my meter in series. There we go. And I've got 0.23 amps. And lastly, they want me to measure the current over here between the last bulb and the power source. So I'll reconnect my circuit the way it was. And I'll measure the current over here, so I'll disconnect this wire and put my probe in series. There we go. And my meter turned off on me here. There we go. 0.23 amps at that location as well. Okay, now we're ready to fill in data table 4. Using the voltmeter, separately measure the voltages across each of the 3 bulbs and the power source. Okay, so here we go. I'm going to change my meter to measure volts. And then I'm simply going to place my probes across the circuit element that I want to measure. So the first voltage measurement across the power source will be the measurement from the red wire to the black wire. .43 volts. Our next measurement across bulb 1, of course that's the same as the measurement of across bulb 2 because they're in parallel. 0.93 volts across bulb 1 and across bulb 2. And then lastly, across bulb 3, .39 volts. The last part of the lab, part 4, the electric power. This is all numbers that you get from your data tables that you previously recorded, and do calculations with those numbers. So this is something that you just do with your data. There's no more lab work to be done for part 4.